I'm Thomas Cameron. I'm the chief architect for the central region of the United States at Red Hat in North America. Today we are going to be doing a session on how to do a demonstration of Red Hat OpenStack 5 or Red Hat Enterprise Linux OpenStack Platform version 5. This is not intended to be a comprehensive installation guide. This is really intended to teach you how to set something up on a regular desktop class machine, or perhaps if you have an extra, whoa, somebody logged in from another room. Somebody logged in from...
Yeah, this is Quentin.
Hey, Quentin, would you mind terribly logging out? I'm running session B from here.
Yeah, I asked you to start 5 minutes past the hour. It's already time?
Yeah, it's according to my clock, it is.
And
Sorry.
This is track B.
What's that?
Yeah, all right, gotcha. Good luck.
All right. So as I was saying earlier, the goal here is not to have a comprehensive installation guide for OpenStack Platform version 5. OpenStack Platform version 5 is still a beta. It's frankly fairly rough. It works pretty well, but I wanted to talk to you about some of the things that I've run into when trying to get it set up. So with that, I'm going to go ahead and share my desktop. And I want to show you the way that I set it up. What I did was, in order to have a machine that I could do an all-in-one installation, but still get decent performance out of, there were a couple of Quickstart considerations that I needed to be aware of. So what I'm going to do is I'm going to share my desktop. All right. So can y'all see my desktop now? Can somebody give me a yes or a no? All right. So it looks like my desktop is being shared. All right, good. So I'm going to open up a terminal. And I'm going to look at the Quickstart that I used to build my OpenStack instance. I'm going to maximize this and make the font a little bit bigger. Oop. All right, so a couple of things that I want to point out in the Quickstart that are important so that your installation will work. Now, I just installed off of a local resource. You could do this off of a satellite server or anything like that. A couple of the things that I ran into were that you need to make sure that Iptables is turned on. So in the Quickstart file, I had firewall --enabled --ssh. One of the things that will happen if you do an automated installation or a Quickstart installation using Packstack is it is going to look for the Iptables service to be stopped or started as part of the installation. If you have the firewall disabled, when it tries to stop the firewall, it comes back with an error code and Packstack will fail. So be aware of that and make sure that you do have Iptables enabled. Now, I set SE Linux to permissive.
Thomas.
Yes.
We can't see your screen.
Oh, okay. All right. Can you see it now?
It's coming in, yes.
Thank you. Sorry about that.
Thanks, Thomas.
No problem. No problem. All right. So the first thing that I talked about was enabling Iptables or the firewall. So in the Quickstart section, I had this. The other thing that I wanted to point out is that I did have SE Linux set to permissive. Normally, I would not do that. You guys who know me know that I'm a big SE Linux guy. So normally I would absolutely have SE Linux set to enforcing, but because we're using beta software, just to avoid any problems, I set SE Linux to permissive. So the sort of tricky part is that if you want to demonstrate sender, you need to have a volume group called sender-volumes. So in the Quickstart file, I created a partition that was a physical volume and I gave it a size. In this case, on the machine that I did this on, I was able to do about 40 gigs worth. And then, so after I've created the sender volumes, or I'm sorry, the physical volume, then I do vol group sender-volumes, and I write that onto that physical volume that I defined earlier. Then what I need to do is I need to create a partition that's going to be mounted on /serve/node/device1. I made this one about 40 gigs as well, and I'll show you why in just a few minutes. This is another storage or another backing store that I'll get to in just a few minutes. And then as you can see in the rest of it, I really didn't do very much. I just did a base installation. A couple of things that I did in the post-install section was that I had to change the ownership of that /serve directory, and I'll show you why. Let me see if I can, oops, hang on a second. I'm logged into one of my OpenStack machines, and if you look at the serve directory, that becomes part of Swift. So as we're doing a demonstration, if you want to be able to demo Swift and you want to give it its own partition, then even though the Swift user account doesn't exist yet, you still need to do a chown of 500 and 500 to /serve. And then I also did a restore con. Ooh, there's a typo there. I did a restore con of that. It doesn't really matter. The context will get set later. And because of a bug in the RHEL 6.5 Quickstart, for whatever reason, even though we defined the volume group as sender-volumes, there's a bug where it ignores that hyphen. So you need to use VG rename in the post-install section to rename sender volumes to sender-volumes. Just be aware of that. Now, because I'm doing this on an isolated network, you guys probably wouldn't need to do this, but I created a couple of repository files for my RHEL 6 and for the OpenStack 5 beta repositories. Again, if you're doing this off of a satellite server or off of really pretty much any place else, you may not need to do this. I just did it so that I would have those repositories available. And then, just as a convenience thing, I did yum-y install OpenStack onto the machine that's going to be my OpenStack all-in-one. So, any questions there? All right. So the next thing that I did was I ran Packstack, and I did an all-in-one installation, but the syntax was a little bit easier. I'm going to change desktops. If you guys lose sight of my desktop, please hit the space bar to speak and let me know. So the syntax for the Packstack command is fairly important. I ran Packstack, and I did the -- all-in-one, because that does a lot of setup on, it actually sets up my network, all my networks, all my subnets. It installs the Ceros image. It does a whole bunch of work for me that otherwise I'd have to kind of go in and hack the answer file and make a bunch of changes to. So I did the Packstack -- all-in-one, and I did pass it the -- sender-volumes -create equals no. And I did that because I've already created the sender volume. If I don't tell it not to create a sender volume, it'll create a loopback device and your performance will be terrible. And I also said the Swift storage --os-swift-storage, I gave it the IP address of my host and the block device that I mounted under /serve/node1, blah, 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 blah. So those are the only two things that I did differently with the Packstack file. Now, the beauty of it is that it ran through, it asked me for my root password so that it would create the SSH key so it could log in and create, install all the RPMs and run all the Puppet manifests. But as I scroll down, you can see that, for instance, there's where it said, oh, there's already a sender volumes there. And the big thing is that everything's green. It ran through and it did the entire installation. It didn't fail anything. It set up, Nova networking. It set up Horizon. It set up Swift. It did all of these things. And when it got done, it created 2 config files. It created the Keystone RC for the admin user and the Keystone RC for the demo user. I'm going to maximize this and make my font a little bit bigger, so hopefully you guys can see this a little bit better. If I look at, actually, let me do an ls real quick. If I look at my packstack answers file, it's the beauty of this is now that I've got this answer file, if I want to go and make changes later on, or if I want to modify this and install it on other machines, I've got a good template for an all-in-one installation. And there's not a whole lot that's actually very different. So when I scroll through, the things that I think are relevant is that, I told it to install Glance and Cinder, Nova, Neutron, Horizon, so you can see all these things. And because I did the all-in-one, it also installed Swift. It installed Ceilometer. It did not install Heat. I probably could have, done the install of Heat as well, but it did create the RC files. I skipped over NTP configuration because I'd already set time on this machine. Let me scroll down a little bit. A couple of things to be aware of. I'm going to move down past here. These are all the settings for, AMQP. I'm going to bounce down a little bit. Actually, let me do this. So it set up Swift for us, and because we specified the IP address and the block device, SDA3, it actually built my machine with Swift installed there. If I look at what it did around Cinder, so the Cinder volumes create got set to no because I passed that to the command line argument. So the beauty of it is it actually set everything up for us. And when it gets done, it'll say, there's the answers file. So again, you can keep that. And it'll prompt you to go to the dashboard for that host. So I'm going to grab that link. I'm going to scroll. I'm going to go back up here to this browser instance. I'm going to log into that dashboard. And I'm going to grab the password from the admin Keystone RC file. Copy that. I'm going to log in as admin with that password. And here's the beauty of it. Once I get logged in, I'm going to save that site. Once I get logged in, I'm logged in as the administrator. And here's the great thing about it. If I go click on, for instance, networks, and let me make this font a little bit bigger so you guys can see it. It did all of the heavy lifting for us. So it created the networks. It gave us our private network, our public network. It gave it address ranges. Now, these address ranges are not on the address or not on the network that I'm actually on. So in a perfect world, we would go back and either modify that, like delete these public or delete the public subnet and rebuild it. I've been playing around with the packstack answers file. So, oops, hang on a second. So the 172.24. So it actually did create the demo range. What I probably should have done is I probably should have modified that from the command line. But for right now, it's great for just a demo, and I'll show you why. So it created the network. It created the routers for us. It actually, if I dig down into it, it created the interfaces on the routers. So it set the route between my fixed IPs and my floating IPs for the virtual machines. So it did all that heavy lifting, all the things that frankly in Neutron is a real pain in the backside to deal with. It did all of those for us. If I click on images, it actually preloaded that Ceros image. It's a tiny little Linux image. It's only like 13 or 14 megs. It pre-provisioned all of the sizes for the virtual machines for us. So it did pretty much everything that you would expect it to, all the things that historically have been kind of a pain in the backside. So it created this machine that I installed on as a hypervisor. So really, again, the all-in-one installation is a fantastic way to do this. And it even, if I go look under the identity panel, it created a couple of tenants. It did an alternative tenant. It did the demo tenant. So you have a demo network to set up. It's really, really pretty cool. So what I'm going to do is this is the administrative interface. I don't really care that much about, or I'm not going to make any changes as an administrator. What I really care about is the demo user. So what I'm going to do is I'm going to log out as the administrator, and now I'm going to log in as demo. And again, I'm going to go look at the Keystone file, and there's my password for the demo user. Copy that. Paste that here, and I am going to save that site and LastPass. And so now what's really cool is I can go and look at a couple of different things. So under images, right now I've got that Syros image because that's the default image that was installed by the installer. But here's the thing that's kind of cool is if I go and I click, it created my private subnet for me. It created my router for me. And if I go click on the network topology, it actually created all of the linkages for me as well. So here's my private network that's on my 10.0 network. There's the public network that's accessible from the outside. And in fact, I can even see all the settings on the router. So again, the all-in-one is really, really nice. If you've ever tried to go through and configure setting this up from the command line using Neutron commands, it's really pretty painful. So what I need to do, there's a couple of steps that I need to take to get this set up the rest of the way. And so what I'm going to do is I'm going to go over and make a couple of changes. First, I'm going to start over here in Access and Security. I'm going to click in Access and Security. When I create a virtual machine or when I create virtual machine instances, there are a couple of things that I need to do to make those things available. So the first thing that I need to do is I need to grant access to those virtual machines over the network. Now, by default, the default security group rules, the security networking rules are super restrictive. You can't get to any of your virtual machines. So what I'm going to do is I'm going to click on Add a Rule, and I'm going to create a custom TCP rule for ingress, in other words, for traffic going into my virtual machines. I'm going to say that I'm going to allow access on port 22 because that's SSH. And the remote address, I'm going to define CIDR, but I'm going to set the CIDR to be anything. So anything that needs to access my virtual machine on port 22 is going to be allowed. So I click on Add, and it shows up there. There's my rule for SSH. And let's say that this machine is going to be a web server. So what I can do is I can set another rule that says port 80 from anywhere. So I'll add that. And then I want to add 443 as well. So I'll do port 443. And that way I can SSH into my virtual machine. And if it's going to be a web server, I can connect to it on 80 and 443. And so now I scroll down and there are my custom rules. And if I want to, I can also add a rule, and I like doing this just so that I have network connectivity. I'm going to do allow all ICMP. That way I can ping it and trace route to it and all those things. So now I've set up my network rules. What I can also do is under images, under my compute overview, now I've got the Syros image, but what if I want to do a RHEL image? Well, that's fairly straightforward. The way that I do that is I click on Create Image, and I'll call this one RHEL 65x8664. Give it a description. Not terribly creative, but it is effective. And I can either give a URL to an image, or since I've already downloaded it, I'm going to choose Browse, and I'm going to go to my external drive. I'm going to go to ISOs, go to RHEL 6.5, and I have a QCOW image that I downloaded from RHN, and it's small. It's only 337 megs. So I'm going to click on Open. I have to define what format it is. This is a QCOW or QEMU copy on write version 2 disk. I can leave the rest of these alone, except I am going to say to make this public so that other tenants can use this as well. I click on create image, and now that image is being created. And while that's happening, varlib glance images, I want to show you what's happened. That file actually got uploaded as this horrible name, but if I do an LSLH on there, you can see it's a 322 meg file. So that is where my RHEL-65 image gets stored, and that 13 meg image, that is my Ceros image. And what's cool is if I run file against these, it'll tell me, yep, that's a QEMU QCOW version 2 image. And the same thing is true for my other one. So this is where those get stored on the file system, because Glance is the image storage service. Just as an FYI, that's where that gets stored. So, okay, cool. I've got an image there. What I find interesting, and I don't know if this is a bug or not, but you remember we saw that Ceros image a minute ago, but now once I've uploaded the RHEL-65 image, all of a sudden the Ceros image doesn't appear to be there. It's still there. I can still access it, but for whatever reason, it gets disappeared from this list. Now, just for giggles, I'm going to choose create image, and I'm going to do a Fedora 20 image as well. I'm going to choose file, browse, go up one level. I'm going to upload a Fedora image, and I'm going to make that public as well. QCOW2, upload image, and as I do an ls-lh, now there's 3 images there, and you can see the file size changed. So it got uploaded. All 3 of those are QCOW images, and now I've got images there. We'll talk about volumes in a little while, but what I want to do now is, now that I've set up my security, or I've set up my security groups, there's one other thing that I need to do if I want to be able to SSH into my machine, and that is I need to create an SSH key or an SSH PEM. And so the way that I do that is I go under here, under security, I go to key pairs, I choose create a key pair. Now this key pair is going to be, I can give it any name that I want, but I'm going to call it my NUC2 key pair for T Cameron. So I'm going to save that as a PEM file. It'll pop up, and I can put that wherever I want. I typically store them under my .ssh directory, just that way I don't lose them. But I can put it on my desktop, I can put it anywhere. I'm actually going to stick it on my desktop this time because we're going to copy this over to the hypervisor in just a few minutes. So I'm going to save that file. It gets downloaded. And it's just a PEM file, nothing really fancy. It's a private key file. So I'm going to save that. I'm going to go back into the web browser. And now I'm ready to start creating instances. So what I can do is in this UI under compute, click on launch instance, and I'm going to get to fill out a couple of choices. So I'm going to give it an instance name. Let's do a RHEL-65 instance first. I'll call it RHEL-65-TC because it's mine. We can give it a size from small, medium, large, extra large, whatever. Now in this case, the machine that I'm running this on has got quite a bit of memory. It's got 16 gigs of memory. So I can go, up to a medium instance. I mean, heck, I think I can even go to a large if I wanted to. Now I don't have enough disk space for that. So I'm just going to go with a small instance, 2 gigs of memory. I'll choose a single instance count, and I'm going to choose boot from image. And then once I choose boot from image, I can drop down and choose which one I want to use. There's my Ceros image, my Fedora image, or my RHEL-6 image. So I'm going to choose my RHEL-6 image. I'm going to scroll down a little bit, and I'm going to click on launch. So what has happened now is it started an image, a RHEL-6 image on the machine. And if I wanted to, over here on my SSH session, if I do a PSAXW, you'll notice that it's doing an image convert. And if I give it a couple more minutes, it's going to copy the kernel over. It's going to keep doing that. We're going to watch this for a couple of seconds. And there we go. It actually ran QEMU KVM. If I do dash wide, and there is my process. So that's the image that got booted up. And if I come over here, then it'll come up and it'll say, yep, it's up and running, and it's been granted an IP address. So the cool thing is it's actually up and running. If I want to see if it came up healthy, I can click on more, come down here and click on the console. And what'll happen is it'll actually start a VNC session over to the machine. And yep, you can still see, whoop, you caught just the tail end of it, that it was booting up. So the image has booted up, it's running, and so I've successfully spun a machine up. Now, what I can do is, if I want to make this actually useful, what I need to do now is I need to associate a floating IP address. That's that public IP address that's going to allow this machine to be accessible from the outside. So I'm going to choose associate a floating IP. You'll see right now it says there are no floating IPs available. I can associate floating IPs a couple of different ways. The easiest way is just click this plus sign. When I click the plus sign, it's going to say, how many do you want to assign, or do you want to assign one? And I'm going to click allocate IP. And now there's an IP address on my quote unquote public network that's available. Now that 172.24.4 network, remember that I said earlier, it's actually kind of a bogus address. Normally I wouldn't be able to access it, so I'm going to cheat a little bit. The assumption is that we're doing this on either your laptop or on a lab machine or something like that you can SSH into. So I'm going to associate that IP address. Now that it's been associated, I can get to that from the hypervisor. In this case, this hypervisor is a machine that's running in my lab right here. So a couple of things need to happen. Before I can SSH in, I need to copy that PEM file over. So what I'll do is I'm going to actually spawn another shell real quick. I'm going to SCP that Thomas Cameron 2 nuc.pem file to nuc2 as root. So now that it's there is my tcameron2 nuc file. Because it is a PEM file, I need to change the permissions on it. If I do an ls-l of that file, you'll see that it's wide open. So I'll do a chmod 600 to that file. And then I'm going to do SSH using that PEM file to that public IP address. And I think that was 172.27. Oh, and you need to log in as cloud-user at that address. I'm going to ask if I want to authenticate. Yes, and bada boom, bada bing. Now I have a RHEL machine running, and if I do an ifconfig, you see that even though I SSH'd to that public address, now I'm actually on the machine that's in my cloud environment. So the beauty is I've spun this machine up, I've instantiated it, it's up and running. If I want to ping external addresses, make sure that I've got network connectivity. Sure enough, that's a public address. Now, one thing that I haven't gotten completely squared away is it's looking for DNS to be running on 10.0.0.3. So if I do, like if I try to ping google.com, for instance, that doesn't work. I haven't figured out what I'm doing wrong on there yet. But so generally what I'll do is I'll just edit the resolve.conf file. I got to fix that. I know that I have done something wrong. I just got to bang it into or beat it into submission. That's a machine that I've got set up with DNS on it. So now if I do a ping www.google.com, there we go. So DNS resolution works. I've got network traffic out. Life is good. I'm going to actually become root on this machine. Sudo su space dash. And I'm going to SCP a repository file so that now I can do a yum group install, for instance, web-server. And this is about as exciting as watching paint dry, I know, but this is just to give you an idea of some of the things that you can do once you've got your virtual machine or virtual machines, multiple, set up. I'm going to get this thing set up as a web server. While that's happening, I'm going to make sure that I can run a web browser off of that NUC. So I'm going to do yum install Firefox and xauth. This will take just a second. Now I'm doing this on the hypervisor. This yum install that you see me doing on the hypervisor is going to allow me to SSH-X in. Let me increase the font size on that again. So I'm doing this on the hypervisor. This is on the NUC box that I brought with me. The reason I'm doing this is because that IP address, that 172 IP address, is not available to the rest of the subnet. I need to do the rest of the demo on this on the hypervisor itself. So I'm going to log out. I'm going to do SSH-X into the NUC. All right. Now on the guest machine, this is that instance that I've got running in my cloud environment. So what I'm going to do is I'm going to check config HTTPD on service HTTPD restart var www HTML echo. This is the cloud instance into index.html. I don't have any IP tables. Oh, I do have IP tables. So, man, this is a belt and suspenders kind of thing. So I've got IP tables running on the guest instance, and I had IP tables running on the host. So let me do this: IP tables, insert into input, protocol TCP, dport 80, jump to accept, and then I'm going to do the same thing on 443. And now that I'm logged on to the NUC, I'm going to do Firefox new instance. So now I've got a new instance of the machine, or I'm sorry, of my web browser. I am again going to grab this URL, and sure enough, I don't know if you guys can see it, this is the cloud instance. So now I've demonstrated that I've spun up the virtual machine. I have passed traffic through to it. I've got the web server up and running on it. And so in, 35 minutes, I guess, 30 minutes, I've gone from literally having a machine that's not configured at all to now I've got a virtual machine running. I've set up my firewall rules, and I've gotten a web instance running on that machine. So not terribly complicated. It's time consuming because there are a lot of steps involved, but literally, I mean, we just went from kind of zero to cloud in about a half an hour. Now, there are a couple of other things that I do want to talk through real quick. Let me get this back over to here. We talked a little bit about volumes. Remember when we did the Quickstart that I set up that sender volumes environment so that we could do volume management. So I'm going to click over here on the volumes tab. Right now we don't have any volumes, so I'm going to choose to create one. And I'm going to give it a name. Not terribly imaginative again, but I'll call it volume 1. First volume in demo tenant. Don't have to give it a type. We're just going to give it a size. Let's say a 5 gig volume. And I'm not going to do it from an image. I'm just going to say create a new image file or a new volume file. Click on create volumes. And it'll take just a second, but boom, it's there. And let me show you something that's kind of cool. I'm logged in over here on the NUC. So if I do VG display, you'll see that my sender volumes volume now has 5 gigs allocated. And if I do an LV display, there is that volume that I just created, and it's 5.0 gigs. So again, I wanted to show you sort of in the background where that stuff got created. And now what I need to do is, if I want to actually have that available on my machine, I will choose Edit Attachments. So I'll click on the More drop-down menu, choose Edit Attachments, choose which machine, in this case the only machine that I've got running, that I want to attach it to, click on Attach Volume, and it'll take a couple of seconds. It'll say that it's attaching. You'll see the little progress bar going. And in fact, if I wanted to go over here to instances, in theory, it'll probably pop up on the screen. You'll see some stuff come up on the screen when it sees the new block device. So let me show the console. It may or may not. Sometimes it'll pop up and it'll actually say you'll get dmessage coming to the screen, but it looks like it's going to make a liar of me, and that's cool. So let me go back. And what I'll do now is I'm actually just going to go back to my SSH session. So this is me logged into that cloud instance. If I do a dmessage pipe tail, okay, there we go. You can see that it threw some messages saying, hey, there's an unknown partition table, but what that means is that there's a new block device. So if I do cat/proc/partitions, sure enough, there's VDB and it's 5 gigs. So, you know, what I could do is I could do fdisk/dev/vdb, and actually I'm going to do fdisk-uc since it's RHEL-5. So I can create a new partition, primary, give it a number, give it a start and a stop. So now I've got my 5 gig partition. I write that, and VDB1, I can run makefs on it. I can even mount that, dev VDB1 on bar_dub HTML, for instance. Now it's empty. And I can even make that permanent by doing a tail-1 of etc mtab, which there you see the correct syntax, and then redirect that out into etc fstab so that it'll be persistent between reboots. So if I cat etc fstab, I've added VDB1 to my machine. And so now I've got a volume that even if I wind up terminating this instance, the volume is permanent. Remember that when you terminate an OS instance, you lose everything that's on that instance. But now that I've got a volume, that volume can be persistent. So if I were, for instance, to have an error on this instance, on this operating system instance, if I really screwed up the configuration or a bad guy broke in or something like that, I can terminate that instance, not a big deal. All I need to do is I just spin up a new instance, attach that volume, and now I've got persistence between instances. So really handy information to have. And if I go back and I take a look in my environment, look at my instances, there it is. It's up and running. It's got some persistent storage attached to it. If I look over here under volumes, it's attached. Life is good. And so now, even though I've got ephemeral instances of the operating system, I have permanent storage that can be moved between guests in my environment. So that's really kind of the 10,000 foot overview. I know that it's only been about 40 minutes worth of demo. You can go a lot. You know, obviously there's a ton of stuff that you can do to make this extensible, but I think that the really important thing to make sure that you understand is I did this on a simple desktop class machine. It's an Intel NUC with an i3 processor. It's only got 128 gig hard drive and 16 gigs of memory. So this is something that I can fit in my backpack and take with me and do demos of. I've actually got a couple of them here, so you can extend this out. But the big thing is this was super simple to set up. There's just a few steps involved, and you can demo this to customers really, really quickly without having to be an absolute guru and go to the command line and do a bunch of crazy neutron commands and Swift commands and glance commands and things like that. The all-in-one installation, to me, is a very, very powerful tool to get you up and running so that you can do a demo in, you know, an hour or so and show customers that it's not rocket science getting this thing set up. So with that, I am going to pop over to here. Looks like there's some commentary. I'm going to look on here to see if there are any questions. If you have any questions, feel free to do it. Just hit your space bar to speak, and I think that's it. Okay, sorry about that, guys. All right. Okay, Srajith is asking, is it Qubit RabbitMQ? It's RabbitMQ. Oh, that's actually one of the things that I forgot to mention. I'm glad you brought that up. It is RabbitMQ. You can do RabbitMQ or AMQP. There's a bunch of different things that can be done. It's really modular. Be aware that when you're doing this installation, that's one of the gotchas that I forgot to mention. I had this set up on an isolated network. There was no network connectivity to the Red Hat network or to the outside. I just brought a little gigabit switch with me. Right now, in the beta of OSP 5, it actually wants to go out and import the RabbitMQ GPG key to do the installation. I think that's a bug because that means that if you try to do this installation on an isolated network, it actually dies and the installer won't continue. So that's a real pain in the backside. Just be aware that that's the case. You do need network connectivity or internet connectivity because the installer will go out and ping rabbitmq.com. So Andrew, shared disks ? I don't know what that means. So if you can clarify that, that would be great. Oh, with the permanent disk, can you do it shared between guests? I don't know. I've never tried. I guess that potentially, I don't know. If you guys don't mind if I blow my OpenStack environment up, let's find out. Because I'm all about blowing stuff up. So let me go to instances. Let me launch a new instance. So we'll call this one TC-2. We'll make it a small as well. We'll do that from an image. We'll select the RHEL-6 image, click on launch. So we're going to let that spin up. And while that's spinning up, I'll pop back over here and see if they're... Yeah, I'm all about blowing stuff up. So let's give that just a few minutes. It'll take a second, and then I'll see if I can attach. I don't think I can attach a volume to multiple machines, but we'll play it by ear here in just a second. Oh, you know what? I'm almost positive you can't, but let's see. Edit attachments. Yeah, I don't think you can. I don't think you can do shared disk because the only thing that it's giving me the option to do is just detach it from the existing instance. We're going to need a bigger boat. All right. Can you do it from the command line? Probably. So the way that you would do that is you would want to source the Keystone RC demo file. And that would be Cinder. I want to say it would be attach. Hang on a second. Man, I'm thinking about it. You've got the snapshot. No, not snapshot. I don't think you can. I really don't think you can. Sender volume. I don't think you can. So. Yeah, can you? Well, yeah, eventually, but I don't know of a way that you can do that. Let me see if this thing's come back up real quick. Hold on a second. My instances. Okay, so it's up and running. Just for giggles, I'll associate a floating IP with it. Boom. So in theory, I don't think you can. So let me go over here to images real quick. Or I'm sorry, to volumes. Yeah, the only thing that's going to allow me to do is just detach from my existing one, and then I would have to attach it to the other one. So unfortunately, I don't think you can use that as shared storage, or at least not in any way that I know how to. All right, any other questions? I guess I can pop that back on, or take that off. All right, so I am not seeing any other questions. I think you can also press the space bar to do audio if anyone wants to do any audio questions. But that's all I've got for today. I hope that this was valuable. The big goal is just that if you do the OpenStack all-in-one with just a couple of command line arguments, where'd it go? History, pipe, grab, pack. Hang on a second. Let me log back in. History, pipe, grab, pack. Huh. I wonder where my pack stack went. Anyway, oh, there it is. No, it's not. Anyway, so the pack stack, I'm going to put all of this into a recipe that I'm going to stick out on my people page. So you should be able to get this within the next probably a couple of days, and then I'll also send the link to Quentin so you guys will have this as well. But again, the whole goal here is you should be able to just do a very, very simple pack stack command, when you get done, the packstack answers file has everything in it that you would need to do, including all the demo setup and things like that. Now, in a perfect world, what I would do, like I said, is set up the demo network correctly. That's the one thing that I think is kind of a glitch, is that it did that 172, the really wonky 172. I think it was like 34 or something like that. But other than that one thing, it's really, really simple to set up. It's nowhere near as complicated as I've gone through the RDO Quickstart stuff. I've gone through the OpenStack docs Quickstart, and those things were, in my opinion, really painful. But if you just do your Kickstart correctly, if you set up the sender volume and the Swift volume beforehand, you get a demonstration that's actually very, very usable. The performance is really good, and the best part is you can do this on your laptop. You can do this on if you have a spare laptop, or if you have something that you can take with you, like a NUC or a small form factor PC. It's super easy to set up, and it gives a very powerful demo, in my opinion. So unless there are any other questions, and it looks like there are not, I want to thank you very much for giving me the opportunity to present today. I really appreciate it. I'm honored to be here again this year. If you liked what you saw today, please let the powers that be know. If you didn't like what you saw here today, just keep your doggone opinion to yourself. And with that, guys, I am going to close the session down. Thank you very much. I appreciate it. I hope you guys have a good rest of the Tech Exchange.